So this three-variable knowledge can be very important. And sometimes we plan to write down some queries to find out all the bars in a sales table. The formula given a sales table with bar B and price as attributes. We have a question to find the bar names of all the bars inside the sales table. And let's assume we have a student writing down a query at the bottom as shown here. You can check if this query can work or not. If we write a query like this, we send a bar from sales where price is less than $2 or price is no less than $2. If we write down a query like this, can we find all the bar names in the sales table or not? If we do not allow the price to be null, then this query should return all the bar names, right? Because if the price is not null, then price is less than $2 or price is no less than $2. Generally, this condition can cover all the price range, right? If the price is not null, then this query is valid. It can return all the bar values, all the bar names. However, in the real world, if we allow the price to have null value, then this query cannot work anymore. Here we show a counter example. We have a bar, Joe's bar, and it sells but, however, we didn't provide the price for its sales records. It is null for the price. If so, if we execute this query on table like this, we will never return the Joe's bar, right? Because according to the price, if we compare the null value versus $2, it will return unknowing, right? If we also compare this null versus $2, it will also return unknowing. Given two unknowings, we use or connect them according to the previous page. We can translate this or as max, right? Then this unknown is 1/2. Given to 1/2, we find max. It is still 1/2. It is still unknowing, right? Therefore, if we have some null value for price, this condition will return unknowing. And this record will never be returned because this condition cannot hold. In other words, we cannot find Joe's bar based on query like this. Then you may wonder, if this query doesn't work, how can we make changes to it? One simple way is to delete the where clause, right? We know it. When we delete the where clause, we just send a bar from sales and semicolon. We finish it. If so, then we can find all the bars in the sales table. And sometimes if we wonder, can we make some changes on the condition to make it work? So we can make some changes to a query like this. We send a bar from sales price is less than $2 or price is no less than $2. Before that, we have another case. Price is null. Or if so, if we change the condition for the where clause into price is null or price is less than $2 or price is no smaller than $2. If so, then this code will work and it will return all the bar names in the sales table. So we have two ways to change this query. One way is to delete this clause. Right. Another way is to make some changes by adding this price is null as a case in the condition. In this way, we can return all the bar names. Okay, so this is a surprising example we plan to show. And we'll show another similar example on this page. So we can test the null values of some attributes explicitly in the where clause. We can use this x is null or x is not null in the conditions for the where clause. And we'll show you another example. We plan to find all the persons in a persons table. We're going to do so by select star from person where the age is less than 25 or age is no smaller than 25 or age is null. In this way, it will include all the persons in the person table. Right. So therefore, when we are writing the queries, please remember some special cases. because sometimes these attributes can be null. If so, it will return some surprising results for your queries if you forget this. Okay, so this is about the three-value logic. Please pay attention to some special cases, especially for the null attributes. So for the queries we show you, they are working on one single table. Remember before we allow the relational algebra to working on multiple relations or multiple tables. If so, then how can we work on this multiple relation to write queries? So we can write down query in a very similar way, and we can write down some interesting queries which combine data from more than one relation or one table. We can do so by listing multiple tables in a from clause. What do we mean? So here we show you an example. We plan to write down a query in SQL by using the relations on the likes between the drinker and the beer and the rate frequency between drinker and bar. We plan to find the beers liked by at least one person who frequents the Joe's bar. Before we talk about the SQL, you should be able to design a query in the relational algebra, right? Here we can show you the result in SQL directly. We can write down the query like this. We select the beers, right? We want to find all the beers. And the beer comes from the likes, this table. So therefore we can write down select likes.beer. And sometimes we may have the same name for the attributes from different tables. If we plan to distinguish them, then we can write down the attributes as relation.attribute, right? It will be seen here we have select likes beer, denoting this beer is from likes table. And in the from clause, we have two tables. The first one is likes, comma, frequency. We have to combine both likes table and the frequency table together, right, to design a query. So for this example, if you write down the query in relational algebra, you need to know, right, we need to work on multiple relations, and we also have to join them together based on some attributes, right? So therefore, in a where clause, we have a condition. It is frequency.drinker equals to likes.drinker. This condition helps us to join this likes and frequency table together with the shared drinker attributes. We join this table together by the drinker name, right? Frequency.drinker and likes.drinker, we need to make sure they match each other. So this is a join attribute we use here between the likes and the frequency. And this frequency.bar equals to Joe's bar. That denotes the specified condition we show in the question. We are working on the Joe's bar. So this condition is for join between two tables, and the tuple condition is for Joe's bar. We want to prune some tuples or tuples. So you can follow me, right, for this true condition we show in this query. Here we're working on multiple relations. And you can write down this query in the relational algebra first, and then you can check back for the select from where this clauses. Okay, this is the example for this multi-relation queries. So for this multi-relation SQL queries, the semantics will be we are working on multi-relation at the same time, and we specify the conditions in the where clause, and we will indicate the relation we are working on in the from clause. And select clause denoting the attributes we plan to projection, right? We plan to project. So therefore, when we see a query like select A1 to AK attributes from some relations like R1 to Rn with some conditions, if we have the query like this, we normally start from this relation we show in the from clause. We calculate the product among all the relations in the from clause. And then we can further apply the selection condition in the where clause to select some tuples. And finally, we do the projection of the design attributes in the select clause to the return result. So if we translate this SQL query in the select from where statements into relational algebra, it actually equals to what? It equals to projection A1 to AK, the design attributes, selection with some conditions in the where clause. Inside we have R1 times R2 times Rn. we calculate the product among all the relations we have in the from clause. So the select from where queries are precise in the projection, join, and select. Inside we have product or joins, and then we do the selection of the conditions, and finally we do the projection. So we can understand this query based on the relational algebra as shown here. We do the projection, selection, and the product. Another way to understand the semantics of this select from where clause in SQL maybe is to write down the query in another programming language like C++. If we plan to implement the same query in C++, what we need to do actually is to checking all the tuples we have in each table. So we can write down the same query as shown at the top, select from where in C++ at the bottom. We can do this query by writing down the C++ program like this, with 4 x1 in R1, x2 in R2, and xn in Rn. If condition hold, then we can add these data tuples into the answer, and finally we can return the answers. It will do the same thing as select from where clauses as we show at the top. I hope it can help you understand semantics of this SQL we show in the select from where on multi-relations. So this is for multi-relation queries. For multi-relation queries, besides the case we showed before, which are really working on the different relations at the same time. And sometimes a query also need to use the 2 copies of the same relation for multiple times. If you still remember in the homework 2, we have one question to find the maximum value from a relation, right? So you need to use the same relation twice in the relational algebra, if you still remember. So if we write down the same query we showed before in the SQL, how can we do this? We also need to use the same relation multiple times. Here we can do a renaming of these different copies of the same relation in the from clause. So we can write down a query. For example, we plan to find a bar which didn't sell beer with the max price. Here we're working on this sales table, right? And we can do so by answering this question with a query as select s1.bar. What is s1? S1 denotes the sales table, the copy s1. We have 2 copies. Besides S1, we also have sales S2. They are different copies of the same table. And here we have a where clause. In a where clause, we have to join between 2 copies based on the same beer names. So therefore, we have one condition to the join between them. S1.beer equals to S2.beer. So we're matching them together, right? To join them together based on the same beers. And we want to make sure this bar never sells the beer with the max price. And we can do so. We have this S1 price is less than S2 price. In other words, this S1 should be smaller than some price in the sales table, right? And hence we can make sure this bar never sells the beer with the max price. In this query, we use the sales table twice. We have S1, S2, and the names of 2 copies for the same relation. In the condition, we have the first one denoting the join condition between these 2 copies. The second one denoting this bar never sells the beer with the max price. It is less than some price in the table, right? Okay, this is the multi-relation query based on 2 copies of the same relation. So I hope you can follow me on these queries, and you can practice these queries by yourself on your computer.